And now we're talking about page 5. And isn't it funny when you go back and look and see what you wrote? STR, you see construction. Okay, so make sure you know how to do the construction. Page 5 is dealing with areas and volumes. You'll have probably a dozen, maybe 15 problems calculating areas and volumes of various types of figures. So let's see, what types of figures must you know how to find areas and volumes of? Well, certainly triangles. If I were to give you a triangle, and if I were to give you the base is 12, and the altitude is 5, I would hope you find the area 1/2 base times height, or 1/2 of 12 times 5. 6 times 5, 30. Okay. What next? How about a square? So if you have a square, and I told you this was 11, and I told you this was a square, and all these were marked, and I said find the area, I would hope that you would know the area is side squared, which is 11 squared, which is 121. In all of these area volume problems, make sure you put down the correct units. If these were centimeters, then the area would be 30 centimeters squared. If this was yards, 11 yards, and this is 11 yards, then the area would be 121 square yards. And whether you use SQ or whether you do yards squared, I don't really much care. Okay, so both of those are good. Suppose I gave you a right triangle, and I just gave you the legs. Let me take some of these away. And so I told you it was a right triangle, and I gave you 2 of the legs. So let's make that a right angle, Joe. Okay, so here's our right triangle. And let's suppose this was 6 and this was 10, and the task is what is the area? You should know that the right triangle legs are perpendicular. So either one of these could be the base and the corresponding altitude. So the area would be 1/2 times 10 times 6, which is again 30. And again, if these are millimeters, that would be millimeters squared. You do not have to find the hypotenuse to do this. You could. So if this were 6 and 10, you know 6 squared plus 10 squared is c squared. So 36 plus 100 is c squared. C is 136. So c would be the square root of 136. I'm not sure that's useful. We don't know this altitude. So we don't know that. So what good would it do to have that? Okay, so that's the area of a right triangle. Suppose I gave you a parallelogram, and I gave you the base and the altitude. You should know the formula for the area of the parallelogram. Here's our parallelogram. Suppose I told you this was 30 going this way, and the altitude, which is this vertical distance, this perpendicular distance right here, was 5. And I said, what is the area? Well, the area of a parallelogram is base times height. So in this case, it would be 30 times 5, 150, with whatever corresponding units squared. Okay, 150 square units. Okay. Area of a circle. Well, we've seen circles so many times. Let's suppose the radius is given as 3 inches. Then the area is pi r squared. So the area is pi times 3 inches squared, which is equal to pi times 9 square inches. Typically, you would write that as 9 pi square inches. Okay, so that would be the area of a triangle. Okay, so there's some area problems. I would hope all those would go fairly quickly. When we get to 3-dimensional figures, now you're dealing with volumes. So what types of things do you need to know volumes? You certainly need to know the volume of a rectangular prism. Think of a box. So if this is given this diagram, and I told you it's a rectangular prism, and this was 3, and this was 2, and this was 5, and all of these were in centimeters, you would have to be able to find the volume of a rectangular prism, length times width times height. So 5 centimeters times 3 centimeters times 2 centimeters. So 5 by 3 is 15, by 2 is 30, and centimeters times centimeters times centimeters is centimeters cubed. That would be the volume. Pretty easy problem. Volume of a square-based pyramid. So let's suppose you have a pyramid now. Think of the Egyptian pyramids. This is told as a square. And let's suppose I gave you the volume, and now you got to work backwards. Okay, so here's your pyramid. And I told you the volume was equal to, let's say, 16 centimeters cubed. And I also told you the height. So now the height of the pyramid would be this distance, this perpendicular distance right to the middle of the square base. I told you that height was exactly 3 centimeters. 3 centimeters. And now the question is, how long is the edge of the base? So this is the side. Okay, so let's see how we might do this. We know the volume of any pyramid is 1/3 because of the point, times the area of the base times the height. And let's see, because it's a square-based pyramid, we know this is side squared times the height. Again, square base, right? The area of this base is going to be S times S, or S squared. So we have this, and now I tell you what this answer is. This is equal to 16. So let's see if we can work from there. Oh, by the way, we already know the height. The height is equal to 3. So let me put that in here as 3. So we have 1/3 S squared times 3. The 1/3 and the 3's cancel. We have S squared is 16. So S has got to be equal to 4. I'll try to make this so that they work out to be nice. Occasionally you'll get some irrational numbers with radicals, but that one wasn't too bad. Okay, let's see, the volume of a cone. A very similar problem. This time I'm going to give you a cone, and I'll tell you that the height is given and the radius of the base is given. So here's your cone. This is the height. So let's say the height is equal to 10 inches, and the radius of the base down here is equal to 4 inches. And your task is to find the volume of the cone. You should know the formula, 1/3 because of the point on top. And then we need the area of the base times the height. But because the base is a circle, this is particularly easy. It's pi r squared times height. And let's see, we have all the information we need here. So 1/3 times pi. The radius is 4 inches, but we have to square that. And then the height is 10 inches. So let's see, we have 1/3 times pi times 16 inches squared times 10 inches. So this looks like 160 divided by 3. 160 divided by 3 pi. And not 160, yeah, 160, and then inches cubed. So this would be our volume. Okay, so the square inches give you that times another inch, so we have inches squared times inches is inches cubed, and then we just multiply the numbers. 16 times 10 is 160. There's a pi, and divide by 3. So that would be the volume of your cone. Okay, so that wasn't too terribly bad. Let me go ahead and stop my area and volume tape right here, and we'll do another one coming.